Hi everyone, welcome back to our channel. So today we are going to discuss about the chopper control of DC motors. So in going to front, let's try to understand what is meant by an chopper. So chopper is generally nothing but chopping the waveform. Okay, so when you have an waveform, for example, at different conditions, you are having the waveform like this and charging and discharging of the inductor. We are going to chop it into one half cycle, second half cycle, one and third cycle. So like this, we are going to chop the waveform. This chopping is called as a chopper control of DC motors. So now coming to the what is meant by an chopper. So what is meant by chopper means generally these choppers are also called DC to DC converters. So the purpose of chopper or the converter is we are going to convert a fixed DC value into an variable DC value. So fixed DC means, for example, take it as some 12 volts. We are going to have the output voltage as variable from 0 to 12. So this sort of thing is performed by choppers, which are also called in shortcut as DC to DC converters. And these choppers are basically have higher efficiencies than compared to remaining power electronics. They have higher efficiencies, and the way you control the speed of any motors by using chopper is very simple. Therefore these choppers has an flexibility in control. So by using the choppers, we can control the speed of an DC motor. So I can say that these choppers has the flexibility to control. Okay, so then compared to conventional way of armature voltage control method and field current control method of a DC motor speed control, rather than using this conventional method, by using chopper we can control it in a flexible manner. That's why it is called choppers has the flexibility in control. And these choppers come with a lightweight. With lesser weight we are going to have these choppers. And one more is, since lightweight, and they also come with a smaller size, and these are dynamically designed. They give you an quick response. The output given by this or electronics, the waveform is like a quick response, fastly charges discharges like this. We are going to have a quick response. So these choppers are going to offer speed regulation down. So that is what the meaning of speed regulation means. This is no load speed, this is full load speed divided by. So here we want regulation down. Automatically this should be higher. So therefore this is nothing but no load speed. So how to calculate this speed regulation down? Okay, so what is the speed regulation down, or generally we call this regulation as a good speed regulation, or this is also called as regulation down. So if you take this speed regulation, so here we are going to have a no load speed of 1500 rpm, and due to loading the change in speed is 1400 divided by no load is 1500. So what is the difference you are going to get? 100 divided by 1500. When you see this is called as the change in speed is 100, which means that the whenever the load is high, the speed is decreased, and the vehicle is able to reach, or this value is improved to 100 by taking required amount of voltage from the stator winding, and this is also able to rotate with 1500 rpm automatically. I can say that our DC to DC converters choppers offers a better speed regulation, or they have regulation down. Regulation down means it indicates that these are able to adjust the voltage and current to the stator and try to maintain the required speed to the load, whatever is demanded by the load. So actually in our electric vehicle drive, we are going to use a separately excited DC motor than self-excited. We are using an separate type of excitation to control the speed in the case of an DC motor traction. I think you know very clearly what are the different speed control methods in a DC motor. We have armature voltage control method and field current control method. By using this, we can run it up to less than rated speed. So here you can, using field current, you can control the speed up to beyond rated speed. And here the one more advantage is the chopper offer a lot of advantages due to its high frequency of operation. So these choppers operate with high frequency operation. Why high frequency operation is possible in choppers is due to usage of power electronic devices. Due to use of high switching frequency power electronic devices like BJT, IGBT, so they have high switching frequency. Therefore, they are going to offer us a high frequency of operation. So this high frequency of operation has one more problem. So this high frequency of operating the switches will create some ripples, which is an unwanted signal. Actually the signal should be like this, but these are going to create some unwanted ripples due to usage of this high frequency switching of power electronic devices, and these ripples are going to reduce the ripple current in the armature. So whenever you are going to reduce this ripple current, it is very important. So the ripple currents get reduced in the armature when you have the ripple voltages produced by the choppers. Next one, due to this high frequency switching, so the period of smaller region of discontinued conduction is reduced. Okay. So when you draw the speed, power, torque characteristics. So here the normal, by using normal method of traction, here the discontinuation, the waveform will be like this. Okay, you can see here. So it comes with constant speed and it has an hyperbolic characteristics. You can see here there is a lot of non-linearity, but by using the power electronic devices, these non-linearity can be reduced. Okay, you can have a smooth control. The non-linearities can be reduced and the discontinuity also get reduced. So why the discontinuity? I mean the discontinuous conduction is reduced by using power electronic devices. If this discontinuous conduction is reduced, means the devices can smoothly operate or have its speed, power and torque characteristics. So within the region of speed, power, torque characteristics. So how this discontinuous conduction is reduced is by using inductors and capacitors. So those sort of how you connect the inductor and capacitor is called as choppers. By using chopper circuits or chopper devices or chopper networks, we are going to reduce the discontinuity of current. If the discontinuity of current is maintained, automatically you can have reduce the discontinuous conduction of components, then automatically you can make the output current as a constant all the time, independent of the supply. So that's why it's very important in a traction motor. So that is well exhibited when you use the DC to DC converters, which is called choppers. So this is all about choppers. Let's try to have a small review of the choppers. So now in detail, now we'll discuss about class A, class B different choppers. So basically choppers are nothing but which chops or which regulates the output voltage. So the waveform we are going to chop out for every cycle. So this is called chopper. So these choppers are also called as DC to DC converters. They convert an fixed voltage to variable voltage. These choppers are made up of power electronic devices and they are going to offer an higher efficiency, and due to this higher frequency of operation, so using power electronic devices, the control, I mean the way you control the speed is very smooth, and these are made up of power electronic devices. They have lesser weight, they have smaller size, and the output given by this device is also quick output they are going to deliver, and they are going to offer you better voltage regulation, better speed regulation. So if the speed regulation is better, where I can understand that it is able to supply the required amount of voltage and current to the rotor, where rotor is connected to the load. So under full load condition, whatever the speed is demanded by the load, that is supplied through the stator, that is called as good speed regulation that is taken care by the power electronic devices. So generally in the DC motor traction, currently we are using a separate excitation type, separately excited DC motors, and these power electronic devices come with high frequency of operation by the usage of by usage of power electronic components. So when you have this high frequency operating type of switches, the discontinuity of the speed power torque is reduced. The discontinuity is reduced means that is the help of maintaining the armature, maintaining the current as constant or current as a continuous will help us to better control the speed power torque characteristics of an electric vehicle. So this is all about the chopper control of DC motors. Now we will discuss about in detail about the need of choppers. Okay. And coming to here, we have different types of control: class A, class B, class C, and different quadrants of operation. We'll discuss one by one. So if you feel the content is useful, so please like, share with your friends. If you have any doubts, let me know in comment section, and subscribe the channel for more updates. So this is a free channel useful for the students. Please try to encourage and promote which will help the students to study well. So thank you for watching.